In this video, I'm gonna do a quick review of integration techniques, use substitution, and by parts. So let me start. I'm gonna solve the integral of x squared cosine of x cubed dx. Okay, I'm gonna find the antiderivative of this function, but how can I do that? Let me give you a small recall of some useful integrals. The integral of cosine x dx, the antiderivative of cosine is sine x plus the constant c. The integral of sine x dx is negative cosine x plus c, because if I differentiate negative cosine, I get sine x. And then the integral of e to some number x dx, this is also very useful. It would be e to the number times x over n plus the constant c. So the integral of x squared cosine x cubed, it's not any of them, so that's why I need to use some techniques to solve it. I'm gonna take this one as my u, and in that case I get cosine of u, which is very good. So I get u to be x cubed. This is my u sub. And so my integral would be the integral of x squared cosine of u. And then I don't know what to do with the x. I don't know what to do with x squared if I write everything like this. So how do I solve this problem? I'm gonna take derivative of both sides in here. So du would be what? Would be 3x squared and then dx. Okay, and so x squared dx is something that I want to replace it with u, so that's why I'm gonna keep x squared dx in one side and I'm gonna divide the other side by 3. And so now this integral, this is my u, would be the integral of cosine of u, and then x squared dx would be du over 3. du over 3. Very good. So you see I have a number which is 1/3. I can bring it out. I can bring any number out of my integral. So I'm gonna write 1/3 the integral of cosine u du. Let me have more space in here. And then you see the integral of cosine of u du, which would be like here with another variable. So it would be what? It would be 1/3. The integral of cosine is sine of u. I'm gonna replace u with x cubed. That was my u substitution plus c. So the answer for this integral would be 1/3 sine of x cubed plus c, where I use basically u substitution. So that was my first example. Now let me give you one example of solving this integral. Okay, I can also use u in here to be 2x, and then I can use u substitution, or I can use the integration by parts to solve this integral. How do I do that? Well, I'm gonna take a function as my u, then another function would be the rest of the integrand would be my dv. So I take something as my u to make my life easier. So I'm gonna take u to be equals to x, and then the rest of my integrand would be my dv. So dv would be whatever that is left, 2x and then the x. Okay, and when I have du, when I have u, I take derivative of both sides. I get du equals to dx, and when I have dv equals to that, I would like to have v, so that's why I take the integral of both sides in here. So the integral of dv would be v, and then the integral of e to the 2x, using this recall that I have in here, would be e to the 2x divided by 2. 2x divided by 2. Perfect. Let me remove this integral sign in here. Now I'm gonna use the formula for the by parts. The integral of u dv would be uv, so basically just the functions, minus the integral of v du. v du, right? So let me solve the integral that I have using this formula. So the integral of x e to the 2x dx, this is my u, this is my dv, would be what? Would be u, and then v is this function that I get, e to the 2x divided by 2, minus the integral of v, this function, e to the 2x divided by 2 du. Du is just dx. Perfect. So this is the function. I don't need to do anything with this one. X over 2 e to the 2x minus, now I need to solve this integral. 1/2, as you see here, is just the number. I can bring it out. Then the integral of e to the 2x using the recall would be e to the 2x divided by 2. Don't forget to have the constant c. You can simplify that, and this is the answer for this integral. X e to the 2x divided by 2 minus e to the 2x divided by 4 plus c. This is the answer for this integral. We can use by parts, the integration by parts, to solve more examples like this. The integral of x sine of x dx. Okay, I'm gonna use by parts for that. I'm gonna just give you some idea. I'm gonna take this one as u, because if I differentiate that, I get 1, which would be easier. My life would be easier. I'm gonna reduce one function, and then the rest would be dv. You can solve it using by parts. Or, for example, when we have the integral of ln x dx, I'm gonna use by parts for that. How? I'm gonna take this one as my u, because if I differentiate that, du would be 1 over x, which is easier than to have a natural log inside the integral. And then the rest would be my dv. You can use by parts for this one as well. There are two other integrals that it would be good if you know the formula of them. It would be 1 plus x squared dx. This is arctan of x. And the other integral, which is very useful, it would be the integral of secant square x dx. Secant is 1 over cosine square of x dx. The integral of that is tan of x. Don't forget the c.